Hi everyone. Today we will discuss related rates in differential calculus. It's the second lecture for this topic. Look at the triangle. In this case, we have two variables, angle theta and side length s. Okay. So for example, if ds dt is given and they can ask you what is d theta dt or vice versa. To solve this kind of question, we must find some relation or equation between theta and s. I think this is the best choice, right? Tan theta equals s over 12. If you differentiate both sides with respect to t with time, then you have a secant squared theta times d theta dt and 1 over 12 times ds dt, right? And these two things are related rates. Okay, so using this information we can solve some situation. Now I have one question. Here, we have a television camera here, and what is that? The shuttle, space shuttle is moving from here to here, this direction. Okay, then definitely s is the variable and the angle of this one is also variable, right? In the case, the height of the shuttle was given with this equation, and unit is feet, time is in second. The camera is 2000 feet from the launch pad, so this one, right? And find the rate of change in the angle of elevation. Yes, we need to find the change of this one, okay? After 10 seconds. So what is the given? In this case, s is a 50 t squared was given, right? And another constant like 2000 feet, and we must find the angle of elevation at 10 seconds. So we must find here rate of change in the angle of elevation. So we need d theta dt, right? So I must start this question by writing an equation between theta and s here. Can you see that? Tangent theta equals s over 2000, and s was given here 50 t squared over 2000. After you cancel out the 10 and 10, 5 over 200 will be t squared over 40, right? So let me copy one more time. 10 theta is a t squared over 40. Now we will differentiate both sides with respect to time. Here. Now left side, derivative of tangent is secant squared, so secant squared theta, then d theta dt by implicit differentiation, right? But right side is a relatively easy one because we have a variable t and we want to find the derivative with respect to t. So this is easy one, right? Derivative of t squared over 40 will be t over 20 by power rule. Good. So we have only one variable here left. Now it's time to find the secant squared theta at time equals 10. Now this is the constant state. Theta here, this 2000. S is 50t squared. Now t is 10, so 50 times 10 squared, which is 5000, right? So from 5000, can you find the hypotenuse? Yes, using these two information, we can use Pythagorean theorem to find the hypotenuse. 2000 is 1000 times 2, 5000 is 1000 times 5, so let me use different color. 1000 here. You may think 2 and 5. Sum of square of these two numbers will be 29, right? So this is the hypotenuse. Now back to here. d theta dt will be t over 20 divided by secant square root theta. One sec. Divided by secant square root theta. And secant is a reciprocal of cosine, so instead of dividing secant square theta, we can multiply cosine square root theta, right? Now plug in. T is 10 over 20, and cosine theta in this picture will be 2000 over 1000 square root of 29, right? This squared. Now first part is 1/2. After cancel out 1000, you will have a 2 over 29 square root of 29. Now if you squared, that will be 4, that will be 29, correct? Now this is a 2 over 29 radian per second. Okay. Let me briefly summarize one more time. If this is S, if this is, for example, 20, now this is theta. In this case, two variables is angle theta and S. To find related rates, we must find some relation between theta and S. In this case, tan theta will be the best choice, right? Very simple and contains two variables. Now, if you differentiate both sides with respect to time, this will be secant square of theta d theta dt equals 1 over 20 ds dt, right? So in the case, please note that these two rates, this is a rate, right, are related. Good. Okay, thank you for watching. See you next time. Bye bye.